Hi viewers, welcome to Ganesh YouTube channel. In this tutorial, I am going to explain you how to create this type of fabrication drawing in Tekla Structures. Okay, let's start. Open Tekla Structures with the Indian environment. Now I'm going to create columns. So click on steel and select this column and zoom it here. Click on here to place the column. Right click on mouse interrupt. Use the shortcut Ctrl 4 for render view. Now we're going to edit this column. So double click on this column. Now deactivate this option, direct modification. Turn it off. Now we're going to change top level 5000 and bottom level 0 and click on modify it. If you want to change the profile, you can change from here, profile catalog. Click on here and we have standard beams here, columns. Just select the profile and click on apply and OK. By default, we're going to take now ISMB 400. Now close it. Now I'm going to create one more column at this location. So select this column and click on here to place the column. Right click on mouse interrupt. Now I'm going to change this column height. So double click on it. Let's take here 4000 and click on modify it and close it. Okay, now I'm going to create beam in between these two columns. Before that, we need to take elevation view along grid A. You can see now these two columns are on grid A. Now we need to create views. So click on grid, right click on mouse, create views and along grid lines. Now click on create and OK and OK. Now open view list by using the shortcut Ctrl I. You can see now we have view list. Now these both two columns on grid A. So we need to take elevation on grid A. So select this option and click on this option to open elevation view and close it. Okay, now I'm going to create beam in between these two columns. So select this beam and zoom it here and pick the first point at the corner of this column, flange. Now pick the second point, zoom it here and click on here to place the beam. Right click on mouse interrupt. You can see now we have column and beam like this. Now click on window and select this 3D view. You can see now we are in 3D view. Okay, now I'm going to create connection between this column to beam. So go to application components by using the shortcut Ctrl F. In search bar, type 186 connection. You can see now we have column with stiffness 186 connection. Select it. Now pick the main part as a column and pick the secondary part as a beam. Now close this window here. Right click on mouse interrupt. Click on space. Right click on mouse redraw view. Now zoom it here. Now we need to pick the rotation point at here to manage the rotation. So use the shortcut Ctrl R and pick the rotation point here and use Ctrl and mouse button to rotate like this. You can see. Now right click mouse interrupt. Now use the shortcut Shift 4 for render view for connections. Now I'm going to edit this connection. So double click on this connection and zoom out here and zoom in here. Okay, now this plate is inclined. Now I'm going to make it as a straight. So click on this plates tab. You can see, click on here and select rectangular, horizontal, vertical position plate edges. Now click on modify. You can see now this plate should be horizontal, vertical like this. Now if you have chamfer at this location, by default you'll get this type of chamfer at this corner. To remove this chamfer, you need to select here perfect rectangle corners. You can see like this. Now coming to these stiffeners, we need to make it this stiffeners horizontally. So click on the stiffeners tab and click on here and select horizontal position stiffeners. Now click on modify. You can see now the stiffness should be horizontal like this. Okay, now I'm going to change this plate position exactly at the middle of this beam. So click on this boss tab. Now click on here and select middle. Now click on modify to see the result. You can see now this plate should be exactly at the middle of this beam. Now I'm going to change the bolt size and edge distance. So click on here bolt size. Now let's take bolt size 20 mm and tolerance 2 mm. Now click on modify it. This tolerance indicates the hole size. For example, bolt size 20 and tolerance 2, then hole size should be 22 mm. Okay, now coming to the lengthwise spacing, we're going to see here. From bolt to the edge of this plate, we can call it as the edge distance. In vertical direction, you can see bolt to edge of this plate. We're going to take here 50 mm and bottom also 50 mm. and click on modify it. Now edge distance should be 50 millimeters. Now coming to number of rows, you can see 1 and 2. Let's take here 2. If you want to create 3, then you need to make it here 3. We require 2 only, so enter here 2. And the spacing between these two walls, we're going to take here 100 millimeters. Now click on modify it. You can see now the edge distance should be 50 millimeter. From first row to second row spacing, we have 100 millimeter and 50 is the edge distance. Now coming to lengthwise, you can control this gap between this flange edge to beam edge, and click on here pictures tab. You can see now column flange edge to beam edge spacing, we're going to take here 10 millimeter. Now click on modify it. You can see now this spacing should be 10 millimeter. Now go to bolts tab. In bolts you can control the beam edge to bolt spacing. For example, let's take here 40 millimeter. Now click on modify it. You can see now beam edge to bolt spacing should be 40 millimeter. Okay, now I'm going to click on here window and select the elevation view to get exact plane view. You can see now from edge of beam to this bolt spacing should be 40 millimeter. Now coming to number of columns 1 and 2, so enter here 2, and the spacing between these two bolts we're going to take here 80 millimeter. Now edge distance from bolt to edge of this plate we're going to take here 40 millimeter. Now click on modify to see the change. You can see now the spacing between column to beam should be 10 millimeter, from beam to edge of bolt to 40 millimeter, and number of columns 2 and spacing 80 millimeter. Now 40 indicates the edge distance. Okay, now click on window and select this 3D view. If you want to change this plate thickness, click on this place tab. You can enter here plate thickness. Let's take here 16 millimeter. Click on modify it. You can see now plate thickness should be 16 millimeter. Okay, if you want to change the stiffener plate thickness, then click on here stiffeners and you can enter here thickness of this stiffeners. Okay, now click on modify apply. Okay, now click on space, right click on mouse, redraw view. Now I'm going to create same connection at here. So go to application compress by using the shortcut Control F and select this column with stiffener 186 connection and pick the main part as a column and pick the secondary part as a beam. Now close this window, right click on mouse, interrupt, click on space, right click on mouse, redraw view. No need to enter the values because the same values you will get previously you have entered. So no need to enter the values here. You can cross check it here, then double click on it. You can see now we have same values, 10 millimeter in plate thickness 16, and bolts we have same values here. So no need to enter again. Okay, now I'm going to create a fabrication drawing for this beam. So click on this beam, right click on mouse. Before that we need to create numbering. So click on this drawings and reports tab and click on here performing numbering and select this option number modified objects. Now click on here save numbers. You can see numbering completed successfully. So now we're going to create fabrication drawing. So select this beam, right click on mouse, create drawing. You can create single part or assembly because it is a single part, so you can select this one or this one. To avoid the confusion, make it as a assembly drawing. Click on here. You can see create drawing finished, one drawing created successfully. Now open drawing here. So go to drawing list by using the shortcut Control L, or you can click on here document manager. Now you can see now we have one drawing here, number B1, assembly number. So double click on to open this drawing. You can see in background drawing is opened, so close this window here. You can see now we have drawing like this. Okay, these are the default dimensions. We're going to delete these all default dimensions and we're going to create from basics. So just select this option, double click on it, select dimensions in drawing, double click on it to activate only this option and drag and select it and delete all dimensions. If you want to delete all part marks, you need to select this option, select marks. You can see only this option is activated, so drag and select it and delete it and select this option, select all to activate all filters. Okay, now I'm going to remove this center line, so double click on the center line and remove this center line tick mark. Now click on modify, apply, OK. Okay, now I'm going to adjust this size of this drawing to reduce it. So double click on this outer rectangle. You can see double click on it, the boundary of this drawing. You can see we have scale 1 by 5. So now I'm going to reduce this drawing. So let's take here 8, 1 by 8, then click on modify it. You can see now drawing size reduced. Okay, now I'm going to increase a little bit. So let's take here 1 by 6. Now click on modify it. Okay, this is more than enough. So click on apply. Okay. Okay, now zoom it here. If you want to adjust this drawing, now click on here boundary around this part, click on it and use the left mouse key, hold and drag and place it like this. Okay, now we have only one part here, beam. So select this beam, right click on mouse, add mark and applied to place the part mark like this. Now click on it and use the left mouse key to adjust the position like this. Okay, this is the assembly mark. We need to place it a single part mark. You can see we have M1. So double click on it and remove this assembly position, select it and remove it, select part position and click on add, then click on modify and see here it should be part position like this. Okay, if you want to place the arrow here, then click on general and click on here and select the arrow head. We have different types of heads here. As you record, you can change it. For example, let's take this default head, then click on modify it to make it like this. If you want to remove the frame, then click on here and select this option without frame, then click on modify it like this. Okay, if you record, then you can place it this frame and click on modify, apply, okay, like this. We have part number M1. You can see in our M1 we have profile information in bill of material M1, and profile information is the ISMB 300 and material is the IS 2062 is the grade, and quantity 1 and total length here, area and weight. Okay, if you want to mention the profile number inside this part mark, then double click on it and select this profile, click on add, click on modify. You can see now we have part number and profile. In between these two parts, if you want to separate these two names, then scroll it down here and let's take here, click on add text and click on add and make it here minus. Now click on OK, click on it and move up. You can see now we have this minus symbol in between these two names. So click on modify it, you can make it like this. Okay, if you don't require this profile information, then select it and remove it, and this minus symbol also remove it and click on modify, apply, OK, like this. Because we already have the profile information in bill of materials, so no need to mention it here. If you require, you can make it. Okay, now coming to total length of this beam, we're going to mention. So click on this dimensioning and select this horizontal and zoom it here, pick the first point here and pick the second point at the edge here, extreme length. Press the scroll button to place the dimension. Right click mouse interrupt to exit the command. You can see now we have total length of this beam from this edge to this edge. We have 5722. Okay, you can cross check it here, 5722, like this. Okay, select this dimension. You can adjust the top and bottom as you record proper position by using the left mouse key, hold it and drag it like this. Okay, we're going to change this arrow head here, double click on it and click on here appearance, click on here. By default we're going to use this type of symbol, arrow shape. Click on modify it. You can see now we have arrow shape like this. Now click on modify, apply, OK. If you want to change this text height in the dimension, double click on it. Now you can see in appearance we have the height 2.5. If you want to increase it, you can increase, and reduce, you can reduce it. Okay, click on modify, apply, OK. Now coming to this cutting portion, we need to mention this horizontal dimension. This is the standard beam, so no need to mention the top to bottom dimension. If you require, you can mention it. Okay, for example, let's take horizontal dimension from this edge to this edge, cutting portion. So select it horizontal and pick the first point here and pick the second point and press the scroll button to place the dimension here. Similarly, you can place it here, pick the first point and pick the second point and press the scroll button to place the dimension. You can see now have this cutting portion 54 millimeter from edge of this corner to this corner, 54 millimeter. Similarly at here also 54. This is standard beam, so total depth of this beam should be according to this profile. You can see we have ISMB 300, that means the total depth should be 300 millimeter. If you want to mention, you can mention it. Select it vertical distance and pick the first point and pick the second point here and press the scroll button to place the dimension like this. Okay, like this. Okay, overall total depth should be 300, so no need to mention here also. Now coming to this dimension, you need to mention these holes, vertical and horizontal dimensions. So select this vertical distance. For example, let's take, we're going to mention these dimensions inside here because this is very clumsy at this location. So click on here first point and pick the second point here, next point and next point and next point here on top of beam and press the scroll button to place the dimension like this. You see from bottom to first hole distance we have 101 and from this distance to this distance we have 114. So from this hole to this hole distance we have 84, from this hole to this hole distance 14, from this hole to top of beam we have 87. Okay, this information is more than enough to mark these holes in vertical direction. Now coming to horizontal, select this horizontal distance and pick the first point and pick the next point here and next point here, next point and next point and press scroll button to place the dimension. You can see from edge to first hole distance we have 59, next hole 18, next hole 61, next hole 18. Okay, these dimensions are more than enough to mark these holes. Now coming to hole size, we need to mention the hole size. So select this hole, right click on mouse, add mark and applied. You can see now I have hole size like this. For number of holes, D indicates the dia, 222 is the hole size, 4 into D 22, hole size 22. This is one type of dimensioning in fabrication. The second method we are going to apply here. So select this option, add free dimensioning and pick the first point and next point here and next point and press the scroll button to place the dimension. You can see now we have the spacing from edge to first hole distance we have 40 and from this hole to this hole distance we have 80 millimeter. Similarly, when you take distance in vertical direction, because there is no inclined dimension edge at this location, so when you take here vertical and pick the first point here and next point and the next point here, next point and next point, and you can place it like this. This is one type of method to create dimension. Okay, to avoid the confusion you can create only one method. This is the best way to mark the hole size dimensions. So click on here vertical and pick the first point here and next point and next top hole and next top hole this one and next top hole this one on top of the beam and press the scroll button to place the dimension. You can see now we have vertical dimension from edge to each hole between distance. Similarly, we need to take horizontal distance also. So select this horizontal distance and pick the first point here and pick the next point. Better to take at the extreme edge of the beam. So select the horizontal and pick the first point here and pick the next point and next hole and next hole and next hole and press the scroll button to place the dimension at here like this. Now I'm going to give the hole size. So select this hole, zoom it and select the only on edge, right click on mouse, add mark and applied. You can see now I have hole size 4 into D 14. Double click on it. You can change the arrow size here. You can click on to general and select here and select arrow size. Click on modify, apply OK to apply the whole arrow. Okay, double click on it, general and click on here and select the arrow. Click on modify, apply OK like this. Okay, now I want to adjust the dimensions here now. So click on it and drag and place it here, and click on this total dimension and drag and place it like this properly, like this. Okay, this information is more than enough to create the fabrication. Okay, that's it. Now use the shortcut Control S for save this drawing and close the window here. To open drawing list, use the shortcut Control L and select it. Here you can see we have completed this drawing B1. So if you want to convert this drawing into PDF, then select it, right click on mouse, click on here print, click on here PDF file, click on here to see the preview. Now click on here open folder when finished this drawing, then click on here print to convert this drawing into PDF. If you want to export this drawing into Autocad file, then select it, right click on mouse, click on here export, select this option open folder when finished this drawing. Now click on export to export this drawing into AutoCAD. Okay, that's it about how to create fabrication drawing for this beam in Tekla Structures. If you like this video, please like it and share it. If you have any doubts, please comment below. For more Tekla Structure related videos, please go to my channel youtube.com/GaniSK. I will provide this link in the description below of this video. Please go through it and come here. Under videos, you can find out so many Tekla Structure related videos. I hope these videos might be helpful to you, and at the top right corner, please click on subscribe button. If you subscribe, you will get notification or updates when uploading new video. So please click on subscribe. Okay, thank you.